Right, let's have a look at these trig questions then. So these are all off maths papers, intermediate tier maths papers. So the first one, calculate the length of the side QR in the triangle PQR below. So QR is there. I can see that I'm given a side and an angle in a right angle triangle. So given the choice of Pythagoras or trig, it's trig. For Pythag, there's no angle information that links to that information. So I'm going to do my three little triangles. So car toa, and I'm going to label my sides. So the hypotenuse is the one that's always pointed towards from the right angle box. So that's my hypotenuse. The opposite is always opposite the angle that we're given or we're trying to find, and the adjacent is the one that's left. So to decide which one of the relationships that we're going to use, we have to include the side we're trying to find, which is QR. So the opposite has to be in it, and we have to include the side that we know. So the adjacent has to be in it. So I'm looking for which relationship includes opposite and adjacent. There'll only be one, and it's tan. So I'm going to be using the TOA relationship. What we then do is cover up what we're trying to find. We're trying to find a side, we're trying to find the opposite. So when we're trying to find the opposite, hang on, got that the wrong way around, haven't I? Good start. So that's one important lesson when you're remembering these. You have to make sure that you write them in the correct order, which I did up there, but then for some stupid reason I got them the wrong way around there. So when I'm trying to find the opposite, I cover up the O. The T and the A are on the same level, so they're connected by a multiply. So the opposite is tan times adjacent. Okay, so O equals T times A. So the opposite is QR, that's what we're trying to find. Tan is always related to the angle. So we have to put that, and when you type it into your calculator, it'll automatically open a bracket for you to drop the angle into. So it's going to be tan of 24 times the adjacent, which is 18. So I've got my A-level calculator on me today, so it's slightly different to yours, but most of the buttons are in the same place. Oh, I need to change something on this. Okay, so I'm going to type in tan, it opens the bracket, 24 close bracket times 18 equals. So that's going to be 8 point, and then unless they tell you otherwise, round it to one decimal place. So that's going to be 8.0 centimeters 1 dp. And that's that. So that's question 1. Question 2 looks a bit more complicated. Triangle of ABCD shown in the diagram below is 35 square centimeters. So ABD. So that's that triangle there. Its area is 35 square centimeters. AD is 5 and BC is 32. And BD is perpendicular to AD. So that's telling me it's at right angles. Calculate the size of angle X. You must show all your working. Okay, so this is a grade B question. It's got 2 stages to it. In order to find angle X, I need to use trig. So let's get my little relationships written down. So I'm going to use one of those. But in order to find an angle, I need to know 2 sides. And at the moment, inside that triangle, I only know 32. So before I can use trig to find that angle, I need to find one other side. That's going to come from this triangle. So we've got a linked side that joins the two triangles. And what I need to do is from this triangle and the information given in there, work out what BD is. So need to find BD from triangle ABD. Now sometimes that might be a separate trig problem or maybe a bit of Pythag, but in this case it's the relationship between the area of a triangle. So I know that the area of a triangle is half times base times height, is the way you tend to remember it, which is always dangerous because in this case, if that's the base, it's no use to us. The sides you need to use are the ones that are at right angles to each other. So it's going to be half times 5 times BD, which is what we're trying to find, equals the area, which is 35. So half of 5 is 2.5. So 2.5 lots of BD is 35. To get the BD on its own, I have to divide by 2.5. So BD is 35 divided by 2.5, which is 14. So I now know that BD is 14 centimeters. Now, usually what I would advise is when you've got this situation where you've got triangles that are all combined or tangled up, just lift out of it the right angle triangle you're going to be working with. So we're now working with a triangle BCD, and we know that BD is 14, and we know that BC is 32, and I want to find X. So we name our sides. This is our hypotenuse, this is our opposite, this is our adjacent. And then we need to decide which trig relationship we're going to use. So we use the one that has got the two sides in that we know, which is A and H. So A and H is the cos relationship. So use K. When we're trying to find an angle, it's the cos, the sine or the tan that we cover up. So cos of the angle is A over H. So cos of X is A over H. So cos of X is 14 over 32. And then to find the angle, we have to do the opposite of cosine, which on the calculator is written as cos with a little -1 above it. So when we're trying to find an angle, it's the inverse of it. So on our calculator, we can type that in exactly as I've written it. Shift cos to get the cos -1, it's in yellow above it. And then fraction button, 14 over 32, close the bracket. Okay, so I've written it exactly, sorry, I've typed it in the calculator exactly as I've written it, press equals, and I get 64.1 or 64 degrees. So that one's a bit more challenging because there were 2 steps to it. Next one is another combined triangle. The diagram shows 2 right angle triangles joined together along a common side. Angle SPQ is 90. So the way that the notation for angles are described, it's basically the letter in the middle is the corner where the angle is. So we're going from S to P to Q. So that's 90 degrees. SQR is 90, S to Q to R is 90. SQP is 38. PS is a side, and that's 8 centimeters, and QR is 15. And we want to work out the size of angle X. So angle X is in this triangle, but at the moment I only know one side. So I don't have enough information inside that triangle to work out angle X. So I'm looking for the side that's common with this triangle, which is SQ. So I need to find SQ in triangle SPQ. So let's just lift out that triangle first of all. So I know that that is 38 degrees, SPQ. I know this is 8, and I want to find SQ. Label my side, name my sides, hypotenuse points to that, so that's what I'm trying to find. Opposite is 8, and the adjacent is the one that's left. So with my SOHCAHTOA, I got to link the opposite because I know it, so I need that value, and the hypotenuse because I'm trying to find it. So S and O are in the sine one. So I'm going to use that. Cover up what I'm trying to find. I'm trying to find the hype, so it's going to be opposite on top of sine. So the hype is op over sine. So for me, the hype is SQ, which is what I'm trying to find. The opposite is 8 over sine, which always links to the angle, which I know is 38. So on my calculator, I'm going to type that exactly as I've written it. So fraction, 8 on the top, sine 38 on the bottom, press equals 12.99, which to one decimal place is 13 centimeters. So I now know that SQ is 13. So let's draw the second triangle now. So my second triangle, that's what I'm trying to find. So that's SQR. I know that SQ is 13 because I've just worked it out, and I'm trying to find angle X, sorry, and I know that that is 15. So I name my sides on this triangle now: hypotenuse, opposite, adjacent. I need opposite and adjacent in order to find the angle because I know them both. Opposite and adjacent is tan. So I'm going to use TOA. I'm trying to find the angle, so I cover up the tan. So tan is opposite over adjacent. So tan of X equals opposite, which is 15, over the adjacent, which is 13. Remember from the previous question, if we're trying to find the angle, we're trying to get the X on its own, we have to do the opposite of tanning, which is tan minus 1, 15 over 13. Type that in my calculator just as I've typed it, just as I've written it. So shift tan gives me the tan minus 1. Fraction button, 15, 13, close bracket, equals 49.1 degrees to one decimal place. So what I always recommend is that when you've got these tangled triangles, split them up, and then they just become more straightforward trig like we were practicing earlier this week. Question 4, another tangled triangle. ABC and CDE are two right angle triangles. So ABC, CDE. In triangle ABC, so that's the vertical upright one, AB is 6.5 and BC is 10.4. In triangle CDE, CDE. CE is 9.4. Okay. BCE is 22 degrees. So B to C to E, that little bit is 22. And ACB is X. So the first thing you want us to do is calculate the value of X. So let's just deal with that right angle triangle first of all. So in triangle ABC, I know that AB is 6.5, I know that BC is 10.4, and I want to work out X. Name my sides. That's the hyp, this is the op, that's the adjacent. So I'm looking for a relationship that links O and A. So car to links O and A is TOA. So I'm going to use that one. I'm trying to find the angle. So it's the tan I cover up, opposite over adjacent. This is just like the last part of the previous question. So tan of X is op over edge, or O over A. Tan of X is opposite, 6.5, over edge, which is 10.4. X is going to be tan minus 1, to get the X on its own, 6.5 over 10.4, shift tan, fraction button, 6.5 on the top, 10.4 on the bottom, close bracket, 32 degrees. Hence, find the length of DE. So I'm in this triangle now. So if I draw that down here, DE, so DCE, I know that CE is 9.4. The length of DE is what I'm trying to work out, and I know that this angle is going to be 32 plus 22. 32 I've worked out, plus 22, so that's going to be 54 degrees. Yeah, 32 was angle X, plus 22. Name my sides, hypotenuse, opposite, adjacent. So this time, I'm looking for the relationship that links O and H. O because I want to find it, H because I know it. So O and H is the sine relationship. So I'm going to use SOH. I'm trying to find O, so I cover it up, and the S and the H are on the same level. So O, or op, equals sine times hyp. Op is DE, that's what I'm trying to work out. Sine always ties to the angle, either the one you know or the one you're trying to find, times the hyp, which is 9.4. We'll type that in our calculator exactly as I've written it. So sine 54, it's important you remember to close the bracket, times 9.4, 7.6 centimeters. So again, to emphasize, separate the triangles out. Don't try to use the horrible tangled one. Lift out the two right angle triangles that you're going to use separately. And then the last question. Diagram below shows two right angle triangles, ABC and APQ. So ABC, APQ. And then the measurements, the dimensions we know, AB is 8.2, BC is 6.4, and PQ is 7.9. And angle CAQ is 90 degrees. So that angle there is 90. Calculate the size of angle X. So angle X is in this triangle ABC. So let's just deal with that one first of all. A, B, C. I know that AB is 8.2, BC is 6.4, and that's angle X. Hypotenuse, opposite, adjacent. So car toa. I need the opposite and the adjacent, so it's tan. So I'm using that one. I'm trying to find the angle, so I cover up the tan. It's opposite over adjacent. So tan of X is op over adj. Tan of X, opposite I know is 6.4. Adjacent I know is 8.2. To get the X, I need to do the opposite of tan, which is tan to the minus 1 of 6.4 over 8.2. So shift tan fraction 6.4 8.2, close the bracket, equals. So 3797 rounds to 38 degrees to 1 decimal place. Right, now I want to find the length of AQ. So AQ is this one, so I need another angle. Now I know that X is 38, so I know that that there is 38. I know that that is a right angle, so this bit in here is going to be 90 less 38. So 90 38 equals 52 degrees. Right, so let's draw my lifted out triangle. This is APQ. I know that this angle here now is 52, and I know that PQ is 7.9, and I want to find AQ. AQ is my hype, 7.9 is my op, AP is my adj. So I need the relationship that includes op and hype, which is sine. I'm trying to find the hypotenuse, which means I've got to do opposite divided by sine. So the hype is opposite divided by sine. So the hype is AQ, opposite is 7.9, divided by sine, which always ties to the angle, 52. So goes on the calculator just like I've written it, fraction button. 7.9 upstairs and sine 52 close bracket downstairs. Side 10.0 centimeters. So that's it. Hopefully, by working through those yourself or working through those with me, you can quickly get into the groove that a question that looks really complicated can be broken down into very straightforward basic level trig. And so long as you're happy with the trig, there's no reason why you can't manage those. Okay, so that's today. Tomorrow we'll take a look at what the trig questions look like on a numeracy paper.